Hey there, today we'll be doing this question that's find closest node to given two nodes which appeared in weekly contest 304. And the question statement is you are given a directed graph of n nodes numbered from 0 to n minus 1 where each node has at most one outgoing edge. The graph is represented with a given zero index array edge of size n, indicating that there is a directed edge from node I to node edges of I. If there is no outgoing edge, it is marked as minus 1. We have been given two nodes, that is node 1 and node 2, and we need to return something. And what is that something? This is written here. Now, this part right here might be a bit confusing to you, or it could be have been very clear to you, but it was confusing to me. Now I'll be explaining this part while I explain you the question part with an example. Okay, so just leave this part for now and let's get on to the explanation part, what this question wants you to find out. Fine. So I've drawn an graph right here. Okay, so the graph which had been given in the question was not a better one. I drew this one so as to make you understand it better on how this is actually working out. So you will be given two nodes, that is 5 and 1 has been given to you. Now you need to say that okay, from 5 what are the nodes that you can visit. Okay, so what are the nodes that you can visit from 5 and what are the nodes that you can visit from 1. So the node that you need to return here is the node which can be visited from both 5 and from 1 also, right? So basically this is something like a intersection. That means if you can visit some node from 5 also and from 1 also, you just need to return that node. And what is given here in this question, this part is you need to return the node which you can visit from 5 and 1, but the minimum distance one. And what do we mean by that? So let's get on to this part. So let's find out what are the nodes that can be visited by 5 and 1 both. So we can see 5 will go here. Let's just do a simple BFS. Okay, and we'll see which nodes can be visited by 5 and by 1 both. So 5 will go here to 6. So 5 can visit whom? It can visit 6. 5 can visit another one who? From 6 we will go to 2. So 2 will also be visited by 5. So we write 2 here. Now it can also visit 3 here. So we write 3. It can also visit 4. How? From this path from 5 to 6, from 2 to 4, right? So these are the ones that was visited. So I'll just remove this part also, and it could also visit 4. So the nodes that could be visited by 5 are 6, 2, 3 and 4. Now let's check on what are the nodes that can be visited by 1, which is given here, right? So the nodes that can be visited by 1 are 2 obviously, from here it will go to 2, 3 obviously, and also 4, right? So these are the nodes that can be visited by 1. So 2, 3 and 4. So let's just write it out, that is 2, 3 and 4. Now the question says that you have been given two nodes, that is 5 and 1, perfectly fine. What are the nodes which are visited by both of them? Mind you, both of them. Okay, so what are the nodes that are visited by both of them? So 2 was visited by both of them, 3 was also visited by both of them, 4 is also visited by both of them. Sorry for that. Now, coming on to the distance part. So I'll be breaking down this question to a simpler manner, okay, so that it is very clear to you. So now coming on to the distance, we are going step by step. So what is the distance needed by 5 to reach 6? So it got to 5 in one step only. See, from 5 to 6, it just went on to 6 by how many steps? By 1. So distance needed was 1. 5 to 2, 2 nodes are there, 2 distance. 3, 2 distance, 1, 2 and 3. So a distance of 3 was taken. To reach 4, it will go to 6, then 2 to 4. Then that means the distance was 3. Fine. So whatever I have written at the top are the corresponding distances to reach it. Fine. So these are the nodes that it can visit, that is 6 to 3, 4, and the distances it took. Fine. Now from 1 to reach 2, what is the distance taken? See, from 1 to 2, it is one node only. So we'll take the distance of 1. To reach 3, we'll take 2. To reach 4, we'll take a distance of 2. Fine. So these are the distances array and the nodes that it can visit. Fine. So till now it is very clear. Now coming on to what do we need to return? I can see that there are some nodes which are visited by both of them, that is 2, 3, 4, and 6 is of no use right now. So let's just remove 6 from here. Okay, 6 we just removed from here. It doesn't really we don't really care about that. Now coming on to what do we need to return, they have told that we need to return the minimized distance of the maximum one. And what do we mean by that? How are we finding the distance? So we actually found out that we can reach 2 by 2 distance also and 1 distance also. Now which distance to take? So in the question they have told you just have to take the maximum distance of both of them. Since 2 can be reached by 5 also and 1 also, 5 reached 2 by how many distances? 2 distances. And 1 reached to 5 to 2 by how many distances? By 1 distances. Okay. So which one are we going to take? From 2 and 1, which are we going to take? So they have said you just take the maximum out of it. So according to them, according to the question, they mean to reach 2, the distance taken was the maximum of 2 comma 1. So this will be 2 here only. Fine. So this is what their definition of maximum here is. But what I read this question as, we had to sum this up. So actually while I was doing it, I summed these distances up. That is 2 plus 1 I did. Okay, but we actually have to take the maximum of 2 comma 1 of both the distances. So this was the mistake that I did at the time, which actually failed on the last test case, sorry. So now it is pretty clear. So what is the time or distance taken to reach 3? It is the maximum of 3 comma 2. Just write this again, the maximum of this and this. Fine. So this is done. Now it is very simple. What do you need to return? You just need to return the node which was visited by both of them. So all these nodes were visited by both of them, and whichever guy has the minimum distance, and the distances we found out, which is the actual distance, that is this. So this is the minimum one. And what is the node that was visited by them? That is 2. So just return a 2. Fine. So that is what they have to do. And this is what the answer is. Okay. So I hope the question is very clear to you. Okay. But still, if you have some doubt, do ask me in the comments. Okay. So yeah, let's now get on to the code part, since the question I have explained and the intuition as well with an example. So the code part is very simple from here. So this DFS is not needed actually. Why did I do this? I don't even know what was going into my mind. But yeah, we just need to do a simple BFS. So what this part is doing, just create an adjacency list. You must be knowing that, very easy. Okay, now this part right here is just taking a simple BFS. We are doing a simple BFS, mind you. You should know this one. So this is a simple BFS code to find the shortest path, okay, with a edge weight of 1. So this is the code that I have written here. And again, I'm telling you, you should know a BFS, simple BFS, to actually do this question. Okay, so again, this BFS part is being done on the node 2. Okay, I've created one, and mind you, I created two distance array, that is first distance array and another distance array, and a visited array for both of them. Fine. After that, this is just the last part. And what does this last part do? It just says if both of the guys were visited, and also if their distances are to be chosen in which manner, in maximum manner. Again, I'll just draw this graph right here so that it's very clear to you. I'll just draw this one, this simpler one right here for explanation purpose. Okay, and we'll just bring this down to this part. Okay, sorry for the long wait. Okay, now we can go. Both are visited. First we see that what is their distance. Now from 0 we can obviously go to 1, and from 1 we can go to 2. So this visited part, I am sure of it, you must have understood it. It's just a simple BFS which we have done here. If during the BFS it is visited, both of them are visited, we will check their distances. So from 0 to reach 1, how much the distance was taken? It is 1, obviously. From 1 to 2, what is the distance? It is 1. Fine. So these are the distances that were taken. And mind you, when we are starting from the node itself, if we are starting from 0, what is the distance taken to reach 0 from 0 only? It is 0, right? And if we start from 2, what is the distance? It is 0 only, right? Because we are starting from there only. Why will we take any distance from there? So that is what we have done here. If both of the nodes are visited, we will check whatever the maximum is. Mind you, while I was explaining the question, how did we take out the distance when both of the nodes were visited? We took the maximum, right? While I was explaining. If you just forgot it, no worries, just replay that part and you'll understand that again. Okay, so we were taking the maximum distance and we are storing the node here. Fine. So this is just storing the maximum distance and the node. Now, in the question, it has been said if two nodes, let's just say for here, the distance is 2 and 1. So let's just forget about this graph. Let's just forget this graph exists for now. Let's just say there are two nodes, that is 2 and 1. Okay, both can be reached from some node by a distance of 1. Okay, so now which node to return? So they have said the node which is the smaller one, you return that one. Okay, so this is what this part, else if part, is doing. That is saying if both the distances are similar, which one to choose? Take the minimum node. So that is why I've taken the minimum node out of it. Okay, and if we never found a node, that is it was int max, okay, return a -1, otherwise what, return the node which you have got. Okay, so yeah, this is it for this whole explanation, and if you want the code, it will be in the description, obviously. Do check it out. And yeah, if you have still any doubts left, please do ask me in the comments. I'll surely be replying to it. Okay, and yeah, this is it for this video, and yeah, thank you for watching.